Okay, once again, my name's Tony Edwards. I'm the warning coordination meteorologist here with the Weather Service in Charleston, and this is our Skywarn Weather Spotter training. This is the first class that we've offered so far this spring. We do have a couple in-person classes scheduled or in the works, and but really love doing these virtually. We've had good success with these, and a lot more convenient to have these in the comfort of your own home. Glad you joined us. It's a beautiful day outside. It was a beautiful day today, actually setting us up for maybe a little bit of thunderstorm activity, some flooding possible over the next few days. So this is really why we need spotters, is for situations like we have coming up. But as far as objectives for this class goes, you can see here on the screen, hopefully by the time we're done here about 8:30, you'll be able to describe your community's severe weather threats. We're going to talk about weather history and what we really do need to be prepared for here in our region. You'll be able to understand the role of a weather spotter and how important they are to our operations. Be able to properly define a severe thunderstorm and identify basic thunderstorm structure and clues to tornado development, provide accurate and timely reports of severe weather. And this really does a couple things. It helps us issue warnings and increases the weather readiness of your community. And we'll talk about severe weather safety plan as well. And so here's the outline. So in West Virginia, this week is spring severe weather awareness, or spring weather awareness week. And in Ohio, it's severe weather awareness week. Kentucky had their awareness week earlier this month, as did Virginia. So this is the time of the year where we really start to try to get folks in that mindset of having to deal with severe weather and flooding, which is kind of a constant threat around our area. So we're going to go into all those details, hopefully get you much more aware and of the issues that we face around here. Again, my name is Tony Edwards. I'm the warning coordination meteorologist here with the Weather Service. I was looking through the list of folks here, a lot of familiar names. Good to see you all again, and some not familiar. So I really appreciate you all joining us tonight. But I'm unfortunately the face of the Weather Service in Charleston. I have a face for radio, but I get out and about quite a bit doing outreach and training and working a lot with our emergency management partners and pretty much everybody that uses our products. So this is one aspect of my job, is educating folks on severe weather issues that we face and training weather spotters. So again, I really appreciate you all joining us this evening. So I'm going to turn my webcam off just to save on some bandwidth here, and so you don't have to stare at me all night. But if you're not familiar with using GoToWebinar, you should have a little box on your screen, and there's a questions box in there. So I'm doing this by myself. So what I do ask for you to do is, if you have a question throughout the presentation, and many of you gave me a sound check and you kind of got a first a test of this questions box, but if you have a question, just type it in the box there. And then when we get through the end of the presentation, I'll go back through the questions and answer those. So that's typically the easiest way to handle questions doing one of these virtual webinars by yourself. So if you don't see that box, you'll see a little thinner box with an orange arrow there, and you should be able to click on that arrow, and that will maximize that box, and you'll see what I'm talking about. If you can't, for some reason, can't hear me, having audio issues, you can always call in and get the audio from a phone as well. And so you could click on phone call there in the box, and it'll give you the information to do that. So we have a lot of resources. When you joined on to the call this evening, you should have gotten a little note that also had this link in it, but this link will come up a lot. You'll see it in the follow-up emails, and it's a really kind of a one-stop shop, all kinds of resources available for spotters. It's weather.gov/RLX/weather-spotter. And this is also where we will place the recording of this webinar on that page for folks to look at. And we have a winter weather spotter class on there from last winter as well. I just briefly touch on winter weather today, since we are heading deep into March, and I think we're pretty much done with winter, hopefully. But we go much more in depth in winter weather spotting in that webinar that's available on our weather spotter page. But a lot of good resources on there. And so check that page out. And also, you don't have to really worry about Oh, the other thing I'll put on there are the slides and a PDF version of the slides used tonight as well. But you don't have to really worry about jotting down any websites or URLs that we may talk about because they're all on this additional resources for spotters page. And plus, like I said, you'll be able to get to the slides as well, which have hyperlinks in them as well. So just sit back and relax and enjoy the information, soak it in, and then when you do have time afterwards, you can go back and look at some of these resources that we're talking about. So I do have the ability to do a quiz here. And so let's test out our quiz function. And I'm going to start one now. And so the poll is open. Yeah. So how is the presentation so far? And let me turn something on here. Yeah. Okay. Now I can see what you all see a little better. All right, so we're getting a good mix of answers here. So I think you're getting the point. Got about 80% voted, so I can see everything I need to see. So yeah, this is a good test, and everybody thinks it's either awesome, amazing, or spectacular. And every one of you all are right. So I really appreciate it. All right, so let's close that one. And I think we're good to go on the quizzes. All right, so let's get into the presentation here. Section 1 is lessons from the past. And so I really love to look back at history, and you really need to when it comes to weather preparedness, because you have to know kind of the weather history of the region you're in order to get a good idea of what you need to be prepared for. And we have weather records in our region dating back to the late 1800s, and it's full of floods. That's our biggest issue here. Severe thunderstorms, tornadoes, wildfires, winter storms, a little bit of everything. You can see the picture on the left. This young man is a cooperative weather observer for the Weather Bureau back in the day. And we have weather observers, or maybe a few of them on here on this presentation. We've got about 60 attendees so far, so I don't see any right off the top of the list here, but we have about 60 or so cooperative weather observers that give us records of weather and go all the way back to the late 1800s in some cases. So that's the information that we look at to really see what we need to be planning for in our region. And really, flooding is the biggest issue that we face. And like I said, we have a flood watching effect for a lot of our region right now going into the day tomorrow, and so hopefully it doesn't repeat itself. But flash flooding is our biggest threat, and flooding kills more people than any other type of weather. And most people, unfortunately, die trying to cross flooded roadways. In fact, in West Virginia, we've already had a fatality this year, and it was the result of someone driving down a flooded road. So definitely something that you do not want to do. We'll talk more about that through the presentation. But the big map on the left shows the flood fatalities since 1990, when we have accurate records, and you can see all of the counties in our region that have unfortunately had at least one flood fatality. And even those counties that haven't had a documented flood fatality, you can see on the right, every county has experienced double-digit flash flood events since 1996. And that's just the reports that we've received over the years. You can see shaded in, find your county, and that's our service area, and you can see the stats there. So unfortunately, about half of all the fatalities on this map were the result of people driving into flooded roads. And here's one event, and I've got some videos in here, and again, this is virtual, so it's going over the internet. So depending on your internet speed at home, you may not be able to see these videos the best. They might kind of jump around a little bit. But this is the flooding that took place in Buchanan and Tazewell counties in Virginia last year. And Buchanan County is down here, and you can see as these thunderstorms move through, notice how they just kind of, I'll play this through again, notice how they just kind of set for a while over Buchanan into Tazewell counties. And this produced some pretty bad flooding. So here's a look at the precipitation accumulation. We actually have, if you have a weather station at your house and you're submitting that data to Weather Underground, we can actually see that data. And here's one of those stations that was in this area of heavy rain. And you can see they got over 5 inches of rain in just a few hours during this period of time, Jewel Ridge, Virginia. And so here's some pictures from the Buchanan County area, one of our counties in Southwest Virginia, as a result of this flood. And this is just one example of many over the years that we've had to deal with in our region when it comes to floods and flash floods. You can see this community completely flooded. And again, just one of many. We've had some tremendous flash floods. 2016 was one that comes to mind in West Virginia, especially in Kanawha County and down into Greenbrier County. So definitely something that we need to be aware of. And if you go to this link down at the bottom of the screen here, again, these slides will be available. We have a story map available that talks more about this flood and goes into a lot more detail. So that's flooding. Let's talk about tornadoes. Believe it or not, we do have to worry about tornadoes in our region. And you folks in Southeast Ohio, you know that you get tornadoes more often than folks in West Virginia, and folks in Virginia and Kentucky get them as well. But this is a tornado intensity. So if we talk about tornadoes, I have to lay a little groundwork and talk about the enhanced Fujita scale that we use to rate tornadoes. And most tornadoes we get in our region are EF0s, EF1s. They're short tracked, they develop quickly, and occasionally without warnings, especially if you're really far away from our radar. Farther you get from our radar, the worse the coverage is, we'll say, and I'll talk a little bit more about that in detail here in a minute. But sometimes we don't even see these weaker tornadoes on radar. Now, once you get up into the EF2s and 3s and the very rare 4s in our region, then those are typically much better detected on radar, but they can be extremely devastating. So you can see the wind speeds and the typical characteristics of these types of tornadoes. Now, the tornado history of our region is actually pretty rich. I mean, we've had out of the 49 counties that are our direct area of responsibility when it comes to weather warnings. You can see that those counties on the map here. We've had 166 documented tornadoes since 1875. The majority of these documented tornadoes, have gone documented in past 30 or 40 years. So there's a lot we don't know about. There's been a whole lot more than 166, but these are just the ones that have been documented. The most in any county are 13 in Washington and Perry counties in Ohio. Kanawha County in West Virginia is not far behind with 11. The earliest tornado that I've been able to uncover in the books is 1875 in Ritchie County, West Virginia, and that was an F2. The longest track tornado actually started in east central Kentucky and tracked through the town of West Liberty into Lawrence County, Kentucky, Wayne and Lincoln counties, and that was back in 2012. The strongest tornado on record actually was an F5, and it's this tornado on the pink here that tracked from Greenup County, Kentucky into Scioto County, Ohio, across Lawrence and Gallia counties in 1968. And then the deadliest tornado was 1944, this red streak up here in the northern part of the map, and this was called the Shinston tornado because it devastated the Shinston community in Harrison County. So you can see we do get tornadoes in our region. The really big ones you can kind of call them maybe a once in a generational thing, but they do happen, and they are something that we definitely do need to prepare for. Find your county, and the map on the left shows you the strongest tornadoes on record since 1875 in your county. And then the map on the right shows you the most recent tornado in your county. And you can see those darker colored counties are tornadoes that have happened more than 20 years ago, back in the 1900s. And so it's been a while. And in a few counties there, Pocahontas, Webster, Clay, Roane, and Calhoun have not had a documented tornado. All these stats are available at our weather hazard risk assessment website, and you can see the URL at the bottom, but again, that's linkable from our weather spotter page, and so you can check that out and find a lot more interesting statistics later on. When it comes to the frequency of tornadoes and when they typically occur, we're at late March now, and typically the tornadoes really ramp up in the late spring, April through about July. That's the peak of our tornado season. We have had tornadoes documented in every month out of the year, though. You can see the chart on the left. Even in January, we've had a tornado. The majority of tornadoes occur between 2 p.m. and 9 p.m. local standard time, and you can see the peak is during about between 5 and 6 p.m. And that's typically when we are at our most unstable, and really that's what drives most of the tornado development. but we can get tornadoes even in the middle of the night. And these are the ones that really worry me because they happen when folks are asleep. And that's why you really need a source, a way to get warnings and some redundancy. Make sure you have a way to get woken up by tornado warnings in the middle of the night. And we'll talk about how to have a good warning system in your house coming up a little bit later. One of the biggest tornadoes I talked about was the Wheelersburg, Ohio tornado. That was an F5 tornado that tracked 45 miles across Greenup County, through the over the Ohio River, and then into Scioto, Lawrence, and Gallia counties. It lifted just before crossing the Ohio River again in Gallipolis. The tornado was nearly a half-mile wide at one point. 7 people unfortunately died in Scioto County and 108 total injuries. So again, we can get large damaging tornadoes in our region. And just through a couple slides in here looking ahead, that we have an agency, a part of our agency that's looking out months in advance, giving outlooks. And so the spring outlook is actually for our region here. The temperature on the left is for above normal temperatures. The precipitation outlook on the right is for above normal precipitation. So we talked about the flooding threat our region sees, and I would say, looking at the precipitation outlook, that flood threat is above normal heading into the spring, and which is typically our busiest time of the year as well. So definitely something to keep an eye on. And just another little nugget, we've had 3 consecutive La Nina winters in a row. If you watched my winter spotter class, we talked about that. We're coming out of La Nina conditions in the Pacific Ocean now, and there's some studies been done that shows there's actually an increased probability of severe weather during the spring months following a La Nina winter. So again, potential for above normal precipitation, and maybe even a slight increase in the potential for severe thunderstorms as we go through the spring. So not good news, but did want to bring that up. So we've got another poll question here. And so let me launch this. And so please tell me what most flood fatalities occur when people do what into floodwaters. And what do you think? All right, everybody's voting, and so far doing a pretty good job. All right, yeah, so we've got 100%, and the answer is drive into floodwaters. So very good, everybody. Everybody got that one correct. Awesome. All righty. So going on to the next section here, spotter guidelines. So this is very important. I'm here to train you tonight to be a weather spotter, not a trainer or a chaser. What's the difference? Well, spotters just basically tell us what's going on, where they're at. Chasers go chasing it. And the big thing to keep in mind here is we will never call you up and ask you to go chasing for us. We won't do that. All we ask you to do is, as you're going about your life, as you're at work or home or traveling to and from, and you see some of the things we're going to talk about, we ask that you contact us and let us know that you've seen them. And we'll talk exactly what we need to know about, but I really don't want you to get yourself hurt chasing. We do have some chasers in our area. I'll show you some video from one here a little bit later on. But it can be a little dangerous around here because of the terrain and vegetation, and it can really limit your visibility, and especially at night it can be very dangerous. So just keep that in mind. If you want to chase, by all means, I'm not telling you not to, but we're not going to ask you to do that. It would that would not be good. So but again, I work for the National Weather Service, and most people don't know what we do. Usually I tell people I'm a meteorologist, and they ask me what TV station do I work for, and I have to kind of go through the spiel here of our mission. And basically we provide weather, water, climate data, forecasts, warnings, impact-based decision support services for the protection of life and property and the enhancement of the national economy. So we are a government agency. We work under NOAA, which is a part of the Department of Commerce, and you can see 122 areas of responsibility across the country. Each one of these are served by a weather service office, just like us here in Charleston. This map shows our county warning area. So again, we cover 49 counties in Ohio, Kentucky, West Virginia, and Virginia, and you can see each of those counties here. If you're on this webinar and you don't live in these areas, don't worry. There's going to be some instructions at the end. You'll get an email. Go ahead and fill that out, and if you're not in our service area, I'll find the office that you fit under, and just about every office will take the training that I've provided, and you can be a spotter for that office. So don't worry about it if you're not in one of these counties. But one of the things I love to highlight is the volunteers that we need to do our mission, and you can see them on this map. And so all the red stars, and this is a little outdated, it's probably over a year old now, I need to update it. But the red stars are all the weather spotters that we have in our database. The yellow, I don't know what that is, the yellow shape there, octagon or whatever, is our cooperative or our CoCoRaHS observers. And these are volunteer weather observers that give us rain and snow measurements every morning. And so you can see those scattered about. And then the blue or the greenish blue squares there are cooperative weather observers, and those folks measure temperature and precipitation every day for us. So really it takes a village to do what we need to do and to issue those reliable forecasts and warnings. We rely on volunteers just like you, and I can't say enough how much I appreciate you taking this class and becoming a weather spotter for us, and really appreciate the reports that you're going to send us later on. But why do we need all these folks? Why do we need these spotters? Well, you know, we have a really neat tool called Doppler weather radar, and it's our primary tool for issuing warnings and monitoring the weather. I've got it up right now, and I'm seeing some thunderstorms up from Pittsburgh back to Columbus that are developing and moving through, and so we can see our radar, we can monitor Pittsburgh's radar, pretty much every radar in the country we can monitor in-house. And the radar is just a gigantic, looks like a satellite dish, and it rotates around, emitting a weak beam of electromagnetic radiation that when it intercepts a raindrop or a hailstone or a bird, it's reflected back, and that dish picks that signal up and turns it into the pretty pictures you're used to seeing on TV of the storms and rain and snow. Unfortunately, fortunately, it's a Doppler radar, so we're able to pick up velocity and wind speeds and direction aloft as well. But unfortunately, one of the limitations of radar is that as you get further and further away from the radar, the beam of electromagnetic radiation that we're sending out gets higher and higher up in the atmosphere. And of course, the Earth is round, so the farther from the radar, the higher up in the clouds we are monitoring, and so we miss a lot of stuff. You can see in this graphic here, the path of the radar energy is well above the funnel, the actual tornado that you're seeing there circled. So while we may be able to tell that that storm is rotating, and we may get the sample the mesocyclone, that rotating column of air in that storm, we are not looking at the tornado. And so that's where you come in. You tell us what's going on at the ground. You're our eyes and ears in the field. Here's some of the information we get back from our radar. Of course, reflectivity is the intensity, the location of those storms and rain or whatever we may be sampling. Brighter colors mean heavier precipitation, and then we also get velocity. A whole lot more information available from our radar as well, but this is the two main ones that most folks are familiar with. And velocity tells us speed moving away from the radar and speed moving towards the radar. And when you have those kind of close together like you have in this image down here at the bottom, there's actually rotation there, and that's a good indication of a potentially developing tornado. So your role is basically to verify what we see on radar, and doing so, putting what we see on radar, that information, our scientific background, in with your information, your ground truth, putting those together makes a credible warning, and it does really save lives. A lot of times the warnings that we issue lack a specificity. We may issue a tornado warning and it says Doppler radar indicates a tornado on the ground. But then when you call us and say you spotted a tornado, or you know, you're spotting maybe a funnel cloud that's reaching the ground, we can actually put in that warning that a trained spotter or an emergency manager or law enforcement indicates a tornado on the ground. And when people hear that tornado on the ground piece, that really gets them to taking notice and taking shelter. And so again, what you do is very important, and your accurate reports really do help us issue much more credible warnings and do save lives. And so we really appreciate what you do. There's a lot of ways you can send us reports, and a lot of information, a lot of different ways to do it. Really no excuse not to be able to get a report to us these days with social media and email and phone and all this kinds of stuff. So, but if you need a refresher, we do have a web page, weather.gov/RLX/reports, and we have all this stuff that I'm about to go over kind of summarized for you. And then also down on that page, you can find tabs that show you exactly what we need from our spotters. And then you can even view the reports that we get. So anytime we get a report, if we deem it credible, we will send that report out as a local storm report. It'll give the location and what is happening there. And so you can find all those reports on that page as well. But the two easiest ways to get a hold of us are, we have a spotter report form, and you can see the link there. Again, all this is available on that page, but it's inws.ncep.noaa.gov. And this is a mobile friendly kind of page you can pull up and you can send your report. It's also available on a PC. And so the good thing about this is it automatically routes your report to the appropriate National Weather Service office. So if you're traveling, maybe you're a truck driver. I get a lot of truck drivers that take the training and they want to know, do I need to keep up with every phone number to every Weather Service office across the country? Well, no, you don't. You can just use this report form, and it'll get you to the right office. One thing that I want to highlight here is if you use this form, at the very last page that comes up when you're trying to use this form, it'll ask you for you'll see custom groups, and if you select trained spotter, then that'll tell us that you're a trained spotter, and we'll properly attribute the report as coming from a trained spotter. And that's good information. We value reports coming from trained spotters more than just a general public report, because we know you've had the training, and so it's important to let us know that. Once we're done with this training, you will get an email, and I'll talk a little bit more about the process after the training, but as part of that email, you will register as a spotter. You'll give us your information. We'll add you to a database, and then I'll in turn send you the 1-800 number that you can use to call us in a pinch. And so that's provided after registering. So you'll tell us who, what, when, and where when you call us. And real-time reports are best, but delayed reports are also extremely helpful. Social media. So sure, everybody on here has heard of Facebook. Many of you probably heard of Twitter. We are on there, so you can follow us at NWS Charleston WV, and we provide information on there, and it's a great way for you to provide information to us. You can snap a picture and share that on our Facebook page. You can direct message us on there, and also on Twitter as well. But pictures of damage are great. And just be sure to post your location when you use social media. Sometimes that can be hard to ascertain depending on how you've got your privacy settings set on there. But we just need your rough location. That really helps us figure out where that damage occurred. We have an app that's available that you can use to report various types of weather. It's called MPing. And so just search for MPING in your app store, and you can tell us when it's raining, when it's snowing. You can tell us how large the hail is you're getting at your house. You can tell us about wind damage. Really neat, this winter they actually added the functionality where you can tell us if snow's starting to stick to the roads, or if you're getting any impacts from ice and stuff like that. So it may not sound like much to you, but it's extremely helpful to us trying to forecast these winter storms, and then trying to forecast severe weather. It's incredibly valuable to get those reports, and MPing is a great way to get them to us. It doesn't take very long, really quick process. I see a lot of ham radio folks on here, and so I want to talk a little bit about radio communications. We moved our office late September to the West Virginia Tech Park here in South Charleston. And with that, we were able to revamp our amateur radio equipment. We've got all new equipment, 2 meters, 440, HF. It's in various stages of getting set up. We don't have HF capability yet. The antenna has not been installed. But we're getting there. And so we are working on building out relationships with amateur radio groups in our service area. And in past offices I've worked at, we've had really good success having clubs and groups across the area do Skywarn nets and then pass us reports over either ham radio or in a chat room, internal chat room, if we weren't able to actually reach them on 2 meters. So it's something I'm working on, and I want to get out and work on that some more. So you may be hearing from me in the future, but just know that we're getting spun up again, and hopefully we'll be able to get some reports over amateur radio before too long. We also have NWS talk groups on the Siren radio, which is a system that's used in West Virginia, emergency management, 911, what have you. So we are also able to communicate that way. And while I'm here, we're really tied in with 911 centers as well. So, you know, as reports are received from 911 centers, we're working on ways to get those reports in more efficiently without burdening the 911 centers as well. So again, we cast a big net. We're getting reports in from all over, and really, all the reports are important to us, whether they come from train spotters or 911 centers or ham radio operators. And so we're just trying to diversify as best we can when it comes to getting reports in. Cocoa Raws, I kind of mentioned this before, but this is a kind of a volunteer network. And if you're a spotter and you're kind of a weather weenie like me and you really love the weather, then I encourage you to maybe look into becoming a Cocoa Raws observer. It's a little more of a responsibility. We do ask for folks to send us a report every day. You get a rain gauge, costs about 35 bucks, and it measures up to 11 inches of rain. It's a manual gauge. They do want manual gauges because we use these measurements to check all the automated equipment, whether it's our radar or the other equipment that we have going on measuring precipitation. So it's still important that we have humans to measure precipitation, and Cocoa Raws is a network that allows you to do that. There's an app on your phone, so it's every day. I've been a Cocoa Raws observer since 2008, and every morning I just go out and measure the precipitation, measure the snow if we've got any, and send that report in on the app on the phone. And it's extremely useful to us as meteorologists to have Cocoa Raws observers all over the region. You can see a map on the left that shows we have some clusters around the area, but there's a lot of gaps in observers. So if you are interested, please, you can search Cocoa Raws, look it up, and become an observer for us. So what do we need to know about? We need to know about tornadoes, funnel clouds, and wall clouds for sure. If you don't know what a wall cloud is, just hang tight. We'll talk about that in just a minute. But if it spins, if you see rotation in the clouds, let us know about that. That's very important. We want to know about hail, storm damage, flooding, heavy rainfall. If you've got a rain gauge, you get an inch of rain in an hour or more, let us know about it. Wind damage, winter weather. We'll talk about that briefly at the end. But any of these things that you see, wind damage, I'm even talking about trees down. That seems to be one that folks think that we don't really need to know about that, but we do. If you're seeing tree damage, you're seeing trees down, large limbs, certainly structural damage, please let us know about that. And again, a great way to do it, snap a picture, add us on Facebook, or you know, send it to us on Twitter, however you want to get that to us. All right, so another quiz. Let's go to this one. Okay, so what do you think? Is this a good spotter report? Hello, I'm a spotter in Ripley, West Virginia. I have marble-sized hail falling outside. It began 3 minutes ago. What do you think? All right, the votes are coming in. Okay, so this is pretty evenly split. And I used to be able to show results on here, but I can't figure out how to do that right now. Let me see if I can move it over here. No, you can't see that. Well, I'll just read them to you. I'll have to figure that out. But it's 52% yes, it's a good report. 48% no, it could be better. So pretty evenly split there, and that's okay. That's let's talk about this a little more. So reporting hail. So that report gave me everything I needed to know. They told me they're a trained spotter. They told me their location. They told me when it happened. However, they use the term marble. And so we do ask, that's the only thing wrong with that report. And so the correct answer to that poll is no, it could be better. So again, tough question. This is one we get a lot. And the reason we don't like marbles is because there's different sizes of marbles. And they go all the way from, the small all the way up to large, greater than quarter size. And so the important thing is to remember is to use coins or balls or something else like that to describe the size of the hail, or better yet, take a ruler and measure it. Of course, do it after the hail stopped falling, because I don't want you to get knocked over the head with large hail. Do it when you can do so safely, but just take a measurement of the diameter of the hail. But don't use marbles. That's the important thing. And you can use that MPing app to quickly and easily send us hail reports. We'll get a notification in our office that that report has hit. And we want to know about the largest size stone that you see. A lot of times there'll be a lot of different sizes, but let us know that largest size. So hopefully that clears that question up. Again, it is, don't use that term marble. Another one we get a lot is hen egg size. Hen eggs, if you got chickens, they vary quite a bit in size. And so use objects that are more stable, like a coin or a softball, or excuse me, golf ball, baseball. And we have had some softball size hail in our area reported over the years as well. So it can get pretty big. How about wind? So I know a lot of you on here probably many of you on here have weather stations at your house. And those are getting to the point now these days where they're relatively inexpensive, and you can hook them up and you can put them on the internet. You can put them on Weather Underground, and we can see that data. And it's really neat, really handy. I've got a personal weather station at my house, and so I know exactly how strong the winds are. But don't worry, if you don't have a weather station at your house, you can use the objects around you to kind of estimate how strong the winds are. And this is called the Beaufort wind scale. And there's a version for sea and a version for land, and you can see the land version, a shortened version of it on your right. So if you're starting to get winds 40 to 50 miles per hour, you can expect twigs and small branches to break out of the trees. That storm, while not severe, is definitely something we want to know about from spotters. Severe thunderstorm is actually one that contains winds of 58 miles per hour or higher. And winds that strong will down large trees, will uproot trees, and will cause some structural damage, knock some, a lot of times some shingles off roofs, maybe some worse damage than that. But that 58 mile per hour threshold is kind of important. That's a severe thunderstorm. And again, so if you see any of that damage, any trees down, large limbs, let us know about it. Tell us how thick the trees and the branches are that are falling. Again, that'll give us kind of an estimate of how strong those winds are. Let us know if the tree's sick. Is it a dead tree that fell? Dead trees can fall with calm winds. I've seen that happen before. And again, let us know your location. Because that's very important, especially if you use social media. Okay, so we talked about that. One more quiz here. Let's go to this one. Okay, so you're at home and you observe quarter-size hail falling outside. What do you do first? Do you run and hide under the bed? Do you report it to the National Weather Service? Do you call up a family member and tell them about it? Or do you go back to watching Wheel of Fortune? What do you think? All right, we're half of the votes in. Now we're 70%. So far, everybody's got it right. Okay, awesome. So just about everybody got this one right. Report it to the National Weather Service. Now, I think somebody said call up a family member and tell them about it. And you know what? That's not a wrong answer. Because a lot of times people need to hear confirming evidence of severe weather. And I know I've seen it, heard about it a lot, where we issue a tornado warning. What do people do? They go outside and look. And I actually heard a story about a guy in Kentucky that did that, and we issued a tornado warning. His cell phone went off. He got one of those wireless emergency alerts on his cell phone. It was about 6:30 in the morning, and yeah, he went outside on the porch to look, and a tree missed him by about 5 feet as it fell. So people look for that confirming evidence, and so if you're seeing that hail, yeah, call up a family and let them know about it. Maybe they need to move a car in a garage, or get to maybe they're outside and they need to get to shelter themselves. So that's a good idea. So I would say, yeah, not a bad answer at all. You could either run and hide under the bed as well, but just take a phone with you and call us. Let us know about it, or let us know by social media or however you want to get that information to us. All righty. So let's move to section 3, thunderstorms. So this map shows the average mean thunderstorm days and over the period from 1993 to 2018. And you can see roughly half of our region is in that shade of 45 to 54 days a year where there's a thunderstorm. And the northern half of our region is slightly less, but basically 40 to 50 days a year we have thunderstorms. Now, not every one of those thunderstorms is severe. A severe thunderstorm is, according to our definition, is one that contains hail 1 inch or greater in diameter, wind 58 miles per hour or higher, or a tornado. Now, tornadoes, we will issue their own warning for that, but severe thunderstorm, if you hear severe thunderstorm warning, you're expecting one or more of these things to occur in that storm. Now, what's not included in that definition is lightning. We don't issue severe thunderstorm warnings based on lightning, but lightning is extremely dangerous. But the good thing is Mother Nature provides her own lightning warning, and that's thunder. So if you're close enough to a thunderstorm to hear thunder, you're close enough to be struck by lightning. But the amount of lightning in a thunderstorm does not determine if it is severe. Only about 10% of thunderstorms are severe. So if you looked at that chart earlier, between 40 and 50 days a year that we have thunderstorms, only about 10% of those are severe. So maybe 4 or 5 days a year you can expect to see a severe thunderstorm in your area. So that's typically how the statistics kind of shake out there. So when we talk about lightning, lightning is extremely dangerous, and most people that are struck by lightning or even killed by lightning, it's because of outdoor sports and folks enjoying the outdoors. And so it's important that if you hear thunder, even if that storm seems far away, lightning can travel up to 20 miles away from the parent thunderstorm. So when thunder roars, go indoors. Leave the field immediately, go inside a sturdy structure such as a home or school or hard-topped vehicles, and wait at least 30 minutes after the last rumble of thunder to return outside. That gives that storm enough time to get a safe distance away. Now, when we're talking about thunderstorms, we need 4 ingredients to get thunderstorms. They just don't happen any time of the year or any time of the day. We need certain ingredients to be in place. Now, I have seen thunderstorms and it's snowing outside. I've actually seen that directly witnessed that several times. But typically the severe thunderstorms, the thunderstorms we're worried about, occur in the spring and summer, and so we have a lot of moisture. It's humid typically around these parts in the summer, and we get a good Gulf flow of moisture off the Gulf of Mexico. You need something to lift that warm, humid air mass up, and typically that's a cold front. It's what we'll be seeing coming through here on Saturday, is a pretty strong cold front that could cause some thunderstorms. But you can even have a thunderstorm off in the distance that produces an outflow. If you ever been sitting outside and there's a thunderstorm off in the distance, you feel that cool rush of wind coming from that direction, that's a thunderstorm outflow, and that can serve as its own little mini cold front that can produce more thunderstorms. So you need a source of moisture, a source of lift. You need instability, and this is cold air above a layer of warm, moist air. And so the best way to kind of describe an unstable atmosphere is a hot air balloon. And the way you get that hot air balloon to rise is you pump hot air into it, right? And so that bubble of hot air inside that balloon is warmer than the air around it, and it causes that balloon to rise. And that's what's going on in that thunderstorm. It's a bubble of air that's got that lift from the front, and now it's warmer than the air around it, and so it's rising up like that hot air balloon. And it'll keep rising until it hits the a stable part of the atmosphere, and that can be many, many thousands of feet up. In order to get the really bad thunderstorms, the supercells like the storm chasers chase, you need wind shear. And that's a missing component in our region for a lot of events. And that's why we don't have nearly the number of tornadoes that they have in, say, Western Kentucky or Kansas or Alabama or Mississippi, where it's a lot flatter. The mountains do protect us a little bit, but we can get events where we do have this wind shear, and that's wind shear is just a change in wind speed, an increase in wind speed with height. So the higher you go up in the atmosphere, the wind increases in speed or changes direction. And so when you have all four of these ingredients together, then you can get some really powerful thunderstorms. Now there's four types of thunderstorms. I've got some videos here. Again, depending on your internet speed at your house, these may not come through too well, but we'll go ahead and play the first one. Single cell thunderstorms. That's your first thunderstorm type. And these are thunderstorms that we get pretty regularly throughout the year. And you can see in this video how that you have an updraft here on this side of the storm. This air is going upwards, and then it's falling out over here. This is where the rain is coming out of the storm. But notice as this storm, and every thunderstorm, mature thunderstorm, has an updraft and a downdraft. But notice as the updraft kind of fizzles over here, this storm weakens, and it eventually rains itself out. Eventually there's nothing but high level clouds and maybe some sprinkles coming out of it. So again, the life cycle of these storms is not very long, less than 30 minutes, but they can contain some small hail and gusty winds. Now the storm over on the right, this is a multi-cell thunderstorm, and notice how the updrafts, they just keep redeveloping. Different kind of air mass in place here. There's some wind shear that's kind of serving as the exhaust for this storm. So the updraft goes up, and then it feeds out, and it allows updrafts to continue to form over and over and over and over. So these multi-cell thunderstorms can be severe. They can have damaging straight line winds, and because notice that it's not moving very much, right? I mean, this area underneath the storm, it just keeps redeveloping, and so we have a flash flood potential. Now let's talk about these downburst winds, these straight line winds a little bit. So a lot of times we will get a storm roll through an area, and we'll get reports of damage. We'll get reports of maybe a tornado that's occurred. There's a lot of trees down, some structural damage. The spotter observer may say that they heard a freight train and then took shelter and come back out and saw this damage. And a lot of people assume it was a tornado, but that's not always the case. And so a lot of times the damage is caused by what's called a microburst. And what's going on in a thunderstorm to cause this is you have, like I showed you before, updrafts and downdrafts in a thunderstorm. And there's processes going on up in there as well that cause some cooling of the air mass. And the updraft maybe causes some rain and hail up in the storm, and then there's cooling processes that cause a kind of a bubble of cool air to kind of form up in that storm, and then all that will fall out sometimes, and you can see that happening here. And there's three images here I'll show in sequence, and you can see this is a downdraft, and watch as that blob, it looks like the lowering of the cloud, that's actually a mass of rain and probably some hail and wind coming out of that storm. Watch as it hits the ground and spreads out. So that can hit the ground with some pretty hard. You can have some wind speeds over 100 miles per hour result from that. And it can be very narrow. It can have a track very much like a tornado. Here's an example of some damage caused by a microburst. And if I put my, let's see. So if I put my laser pointer here in the middle of the screen, so that's your house, all right? Not a good place to be in a microburst, right? Well, notice the tornado. Very similar, but notice how the trees are kind of wrapping around the path of that tornado. The path went from right to left. And so there's definite rotation in that damage. Here's some trees actually getting sucked into the path of the tornado. So it's very subtle. There is a difference there, but I ask you, if your house, again, is located in the middle of this slide, does it really matter whether it was a tornado or a straight line winds? It doesn't. You've got serious problems. And so that's why I really want to reiterate that if you hear a severe thunderstorm warning has been issued for your area, then treat that just like a tornado warning, because a lot of times tornadoes we get in our region are pretty weak, they're pretty narrow, and they don't affect a big area. Severe thunderstorms, on the other hand, can affect a really large area. I mean, we can go back to the derecho in 2012 where it affected the entire area, and that was what we call a macro burst. Micro burst is small, macro burst is large, and so all those were downburst winds. So just keep that in mind. Now, when we talk about multi-cell squall lines, this is the third type of thunderstorm. These are the storms you can see here on the radar image. You can see how they're lined up. There's actually a literal line of thunderstorms moving across West Virginia. And this may be what you see. Again, this is what we see on radar. This is what you might see at the ground. Notice this wall of clouds, and we call this a shelf cloud. And sometimes there's little lowering of the shelf cloud underneath, and some people mistake these for funnel clouds or tornadoes. It's important that if you think you see a funnel cloud or tornado, always look to see if it's rotating. If it's not rotating, it's not a funnel cloud or a tornado. It's just a scary looking cloud. But these squall lines can bring with them a whole lot of trouble, and we can have hail, heavy rain. Really, wind is the biggest threat, but you can also get quick spin up tornadoes with these as well. Now, the worst of the squall line thunderstorm types is called a derecho, and we have firsthand experience of derechos around here, especially if you were around here back in 2012. We had one of the strongest derechos that you can get go through our region, and you can see as it entered southeast Ohio heading towards our region, that line of thunderstorms. And it produced a fairly consistent area of wind damage from Chicago all the way to the western Atlantic, and it did that in about 12 hours. And most of the state of West Virginia was without power. Lots of southeast Ohio, northeast Kentucky lost power, a lot of trees down, and that continued all the way to the DC area. Derechos are a type of squall line, but they're kind of like, if you want to think about it, they're kind of like the F5 of squall lines, or they can be. They can be the most intense version of a squall line, and typically the winds are very, very strong in these. Now, here's a very beautiful video of a shelf cloud, and this was taken by Hunter Riddle. He's one of the chasers that is pretty good photographer, and so I don't know. I didn't look to see if he's on here. Let's see. I'm not sure. I don't see him on here, but took some pretty nice video here of a shelf cloud, and notice how that low-hanging wall of clouds just kind of advances over, and this is a pretty good sign of strong and potentially damaging winds coming at you. And as that goes over, you could see the camera start to shake, and so definitely something that you want to be aware of. If you see this coming, then take shelter, because strong winds are likely to be on their way. Shelf clouds slope down and away from the rain, and you can see here how this is a kind of a side view of the shelf cloud, kind of very similar to what you saw in the video before, but notice how it slopes away from the rain. And that's because that downdraft of air is coming out of that storm and pushing that cloud out away from it. Now, we're talking about shelf clouds because we need to differentiate between shelf clouds and wall clouds, and sometimes that can be a little hard to do. But the important thing is shelf clouds oftentimes won't be rotating. They may be kind of tumbling along, looking real chaotic motion in the clouds, but they will slope away from the rain. Now let's talk about supercells, because this is where when we get these, and we do occasionally, each year we'll get some supercells, and these are the ones that can cause some real havoc. You can see the table at the bottom of the screen. They can have large hail, they can have exceptionally heavy rain, exceptionally high wind, and really large tornadoes. They can bring everything with them. And this may be what you see if you've got a good vantage point. You know, it's rare in our region to get a good view of a supercell. Maybe if you're up on a mountain somewhere, or where it's a little flatter, maybe you can see all the anatomy of a supercell. But as a spotter, you can see the overshooting top, you can see the anvil. This is where that updraft hits the stable part of the atmosphere known as the tropopause, and it spreads out. And we call it an anvil, kind of like the old anvil where they used to fashion metal on. But as a spotter, and I really want you to focus on the lower part of these storms, and you'll notice this part down here, it's a flat, dark looking part of the storm, and this is where the air is feeding up, going upwards into the storm, and this is called the rain-free base. And then all the rain is falling out over here. This is the downdraft part of the storm. Let me go back there. And so when you have the intersection of this updraft and downdraft, a lot of times in these supercells, you'll get a lowering of the rain-free base, and this is a wall cloud. And I'll show you a better example of this in a minute. But this is where the tornado would develop. So this is a very important part of the storm, and as a spotter, this is the part that you want to be monitoring for a lowering of that cloud and rotation, which would be a wall cloud. Now, again, this is what you see. Now, this is what we see looking at our radar. This is a supercell, and this will play through a couple times. Here comes the supercell, and watch this part of the storm here. Notice how it really winds up and it starts to look like a fish hook. This is a tornado that's on the ground, and this is our radar picking up a lot of debris in that tornado. Here comes another one. Here's a supercell, and watch as it develops that hook. There's a tornado on the ground. So that's radar. That's what we're watching. And again, this is what you might see. And this is a wall cloud. And you can definitely see the rotation there. And so wall clouds are a lowering of the thunderstorm updraft base or rain-free base, and the rotation is the key. If you see this, please report it to us, as it's often a precursor to a funnel cloud or tornado development. Now, here's another kind of radar signature of a supercell, and maybe you find yourself here, or maybe this thunderstorm passes over you and this is where you happen to live. What's it look like to you? Well, you can get some large hail. That's where the hail is going to fall out of that thunderstorm. Now, here's the same storm. Now you're located south of the storm. You're looking north towards that hook echo that we showed you on that prior radar example. What's it look like to you? Well, this may be what you see, and so I'm going to walk you through this here. Here's your rain-free base, that flat, dark, ominous-looking part of the storm, but there's no rain occurring underneath it. Let me pause it here. So here's the wall cloud. Notice this lowering cloud attached to the rain-free base, and it's kind of hard to see, but it is rotating. Now, the problem and why it's very difficult to be a spotter, especially a chaser in our region, is the hills and the trees are blocking your view. So we just ask you to tell us what you know, and don't, tell us what you don't know. In this particular example, I'm not sure if that's a tornado that's touching the ground or not, because the trees are blocking me. All I know is that's a wall cloud because it's rotating. It's a lowering part of the rain-free base, and it's rotating. So that's what I would report. For situations like this, it's best to call us. That way we can talk to you, we can ask you questions, you can ask us questions. This is not something you want to report using an app because of the anonymous nature of the app, and we're not able to get any info from you really from that. So tornadoes, anything like that, please call us. That way we can have a little bit of a dialogue about what you're seeing. But this is very important. I'll go ahead and give you a heads up that this did not have a tornado at this time, but about 20 minutes after this video was taken, this storm ended up producing a tornado, and it was a very large tornado, an EF3, that leveled a town in eastern Kentucky. So definitely a precursor to tornado development there, and something that we would definitely want to know about. Now, funnel clouds occur as well, and a lot of times people get these mixed up. or they see a cloud that looks like a funnel cloud and it's not rotating, and they report a funnel cloud. So the question we're always going to ask you if you report a funnel cloud is it rotating? If it's not rotating, it's not a funnel cloud. It's just a scary looking cloud. So always look for rotation. And also, after asking yourself, is it rotating? Ask yourself where it's pointing. Occasionally, like this example, you can get a funnel cloud that looks like it's not reaching the ground, but notice down here you actually have some debris being kicked up. So this is a tornado, not just a funnel cloud. So again, if you think you see a funnel cloud, ask yourself, is it rotating? And then ask yourself where it's pointing. All righty. So here's a couple of or a few examples of some what we call scud clouds, and they're also known as scary looking clouds because some of them be pretty scary looking, and some people mistake them for a funnel cloud or a tornado. And let me page through these and just show you the different examples. Here's one that's really kind of scary looking. So, when you see this, take a second look. Always look at it and see if there's rotation. And again, sometimes these can look very turbulent. That shelf cloud video that Hunter Riddle shared with us earlier was pretty chaotic as that moved overhead. But there's no organized rotation about the vertical axis, and that's the important thing. So if it's not rotating, it's just a scary looking cloud. All right, so let's do a quiz question here. Okay, so according to National Weather Service definition, what makes a thunderstorm severe? And there's 3 things on here. You should be able to toggle them on and vote, but there's 3 different things that we include in the criteria for a severe thunderstorm. All righty, so votes are pouring in. Okay. All right, so I'm gonna close the poll. Okay. And so 7% said continuous cloud of ground lightning, 66% said tornado, 100% said damaging winds 58 miles per hour or stronger, 28% torrential rainfall that produces flooding, and 90% quarter-size hail or larger. So the greatest 3 percentages, tornado, damaging winds, and quarter-size hail, is correct. We've got a few votes for torrential rainfall, and while that may be occurring with the thunderstorm, we don't factor in rainfall as a severe thunderstorm, so we'd issue our own warning for that called a flash flood warning. And then continuous cloud or ground lightning is not a criteria. Every thunderstorm has lightning, and so Mother Nature provides her own warning there, and it's thunder. So very good answers to those questions. So let's talk about weather safety. And now, like I said, it's Severe Weather Awareness Week in West Virginia, Ohio. We just had it in Kentucky and Virginia. Now's the time to prepare for severe weather, and we have a storm coming up. Flood watches out for a lot of the region and potential for high winds. So tonight's a great time to get prepared for severe weather. And so it's important to identify shelter locations before the storm. Hopefully you know where your safest place to be is in your home, but just remember, if you're not at home, maybe you're at work, or maybe you find yourself on a Saturday out shopping, always have in the back of your mind, look around to see where you should go in the event that a warning is issued for tornadoes or what have you. When a watch is issued, plan your day around the weather, and then when a warning is issued, that's when you need to take appropriate action. So a mobile device could save your life. I'll talk a little bit about wireless emergency alerts in a minute. Every cell phone should have that capability to receive tornado warnings and really enhance severe thunderstorm warnings and flash flood warnings natively on your phone. You don't even have to download an app for that. But there's also a lot of apps that you can use as well to get more alerts. And have some redundancy there. Have a weather radio, have a cell phone. Use your local TV and radio media. They're really good at providing coverage during severe weather. So we'll talk more about that But as far as the products that we issue for severe weather risk awareness, there's 3 products. It's an Outlook, and these are issued by the Storms Prediction Center or the local office, but basically it's a large area. You know, you can go to the Storm Prediction Center's website, and maybe you've got plans on Saturday or Sunday, and you can look and see what the outlook is for severe weather for our region. And it'll be a large area, colored various colors depending on the severity of the expected outbreak. And so that's your time, you know, to be aware. Start making some contingency plans if maybe you've got something going on outdoors that day and there's a severe weather risk. Now, once that threat increases, but it's still several hours ahead, if there's a big enough risk for severe weather, or just like we're seeing right now with flooding, then we'll issue a watch, and that could be a severe thunderstorm watch, a tornado watch, a flood watch, a winter storm watch. You've got time to get prepared in this situation. And in this example, we're looking at severe weather risk, and the severe thunderstorm watch has been issued. It's a big orange box covering most of our forecast area. And you may see a watch box go out and look outside and not even see a cloud in the sky. But that's telling you that severe weather is possible in a few hours. And so to go ahead and get prepared. Again, plan your day around the weather. Now, notice the warnings. They're very small. They're pinpointing the exact area where we expect either severe weather, tornado, flooding, what have you. Excuse me. Now, again, the outlooks, you can find those at the Storm Prediction Center, and you can see the web address here, spc.noaa.gov, and you can go there and you can get outlooks for the next several days. A whole plethora of information is available from the Storm Prediction Center. These folks are located in Norman, Oklahoma, and they are the severe weather experts for the country, and all the watches and the outlooks come from them when it comes to severe weather, severe thunderstorms, and tornado. They produce these outlooks that show the pretty colors and highlight the areas under the gun for large severe weather outbreaks. And they use terminology like you see in the chart on your right. And again, the brighter the color, the prettier color, the worse the day. And so again, I encourage you to go to their website and take a look at their outlooks. As far as local weather information that we have from our local office, you can go to weather.gov/CharlestonWV, and that'll pull up our web page. Or you can go to weather.gov/your zip code, and that'll pull up a web page like you see here, where it's a really detailed forecast just for that zip code. And you can actually use this map to even dial into the neighborhood level. And this is called our point and click forecast. There's a lot of graphics available. Mobile.weather.gov is a resource you can use. A lot of people ask if we have an app, a weather forecast app, and we don't, but mobileweather.gov and our websites kind of act like an app. They're pretty mobile friendly, so you can use them, bookmark them, and bring them up, and it'll load the latest data. Like I said, Facebook, Twitter, NOAA Weather Radio, you can get one of those, get a weather forecast 24 hours a day, 7 days a week, and then they're also your own personal weather alert. You can set those up to go off for your area when we issue warnings. Of course, local TV and radio, reliable apps and websites. And there you can see a graphic from mobile.weather.gov. It's kind of what that looks like. So how do you get updates from us? You can see our webpage on the left. I took a screen capture of this earlier today. Notice that we've got a headline up here that tells you more about the expected flood potential. Here is the flood watch. You can click on our weather story graphic to get more updates. Here's a radar, satellite. But notice the red box down here. If you click on that, that'll open up our briefing page. And there's a whole lot of information you can get on our briefing page. And this will give you a whole lot of graphics and tabs that you can drill down to get more information. So I encourage you to look at this. Look at it every day. Pull it up and get briefed on what weather conditions you can expect. We also have a graphical hazardous weather outlook. If you go to our briefing page, you can see it here. And you can click on that graphic or go to the page itself. And this is kind of a neat little dashboard that you can use to get a quick look at the next 7 days and what weather hazards you may face. And the map on the left, when you pull up the page, will be the kind of the worst case element that week. and then you can kind of click on these, we call them chiclets. When they're lit up different colors, you can click on them, it'll change the map, and you can see exactly what part of the area is under the gun for those risks. And again, we have examples for our forecast area, the 49 counties we cover, and also the entire state of West Virginia, as we are the state liaison office for the entire state of West Virginia. Now, there's other ways to get alerts, wireless emergency alerts. Again, should be native on everybody's phone these days. About every phone, unless you have a really old one, you've got wireless emergency alerts on there. And so nothing you need to download. And here's the products that will set these off. So tornado warnings. Anytime we issue a tornado warning, if you're in that warning polygon, then you'll get a wireless emergency alert. If flash flood warning, this is a big one. So flash flood warnings don't in and of themselves set off wireless emergency alerts. But if we expect flooding to go from your typical flash flooding to a atypical flash flood, and we're talking going from the normal flood spots to something that you don't see every year, then we have to add a special tag in that flash flood warning to get wireless emergency alerts to sound. So hopefully we do that ahead of time. But if there's a case where you start getting some really, considerable or catastrophic flash flooding, please report that to us. Let us know that that's going on. And if we don't have that wireless emergency alert set off, then we'll get that set off and warn people not to go into that area. Severe thunderstorm warnings, now we can set these alerts off for another derecho type event. If we're expecting 80-mile-an-hour winds and baseball size hail or larger, then we can set off everyone's cell phone in that area to let them know it's coming. Now, there's a lot of other apps. If you want to notice on this listing, there's an average severe thunderstorm warning with, we're expecting 60-mile-an-hour winds will not set off wireless emergency alerts. So you need to get another app for that. FEMA has an app that allows you to get weather alerts as well as Red Cross, and you can dial these in. You can get the exact alerts that you want. You can set them up for multiple locations. If, say, you've got family members in a different town, you can set these up. So these are two really good apps, and that also have a lot of other information other than weather alerts on them for disaster preparedness. So I encourage you to use those. NOAA weather radio, these are great to have. And again, you can set these up to alert you in the middle of the night of tornado warnings just for your county. They're really kind of like a smoke alarm for weather. They're really handy and can save your life in those situations like I showed you before where you get a tornado in the middle of the night. Emergency kits. It's important to have these made up ahead of time. And you can go to ready.gov/kit and get more ideas of what to include in your disaster kit. But a bare minimum 72 hours worth of food, water, and prescription medicine for you, your pets, your family members, and have that in an accessible area, accessible bag, or some way that you can take it with you if you need to get out of Dodge really quick. And but this is important. Winter storms can keep you isolated for several days. Severe weather, derecho, another derecho happens, and you could be cut off from power and ability to leave your house for a few days. So it's important to be self-sufficient, have these emergency supplies on hand in case you need them. So let's talk about specifics. Tornado safety. Say you get home one day and pull in the driveway and see that coming at you. Pretty scary. What do you do? So here's some guidelines, and it goes from worst options to best options. And so best options, specifically design FEMA safe room or tornado storm shelter. Not too many of those around these parts. I've heard of some people getting grants for those in Ohio, but pretty rare to have a safe room or a tornado shelter in our region. But the good news is, again, most tornadoes we get in our region are those lower end varieties. And as long as you're in an interior room or basement of your structure, then you're probably pretty good shape. Bad options are manufactured housing, large open rooms like gymnasiums, and in the worst options, mobile homes and vehicles and underneath the highway overpass. And let's talk a little bit about mobile homes. So here's a graphic that shows where a mobile home is a single wide trailer sat. And this is where it ended up after getting hit with an EF2 tornado. So mobile homes become mobile in tornadoes, and they're not safe at all. So what I tell people to do is when you hear that maybe a tornado watch has been issued, remember the watch means you've got some time. That's when you want to get out of that mobile home. Go to a family member's house, a friend's house that has a basement or sturdier structure as early as possible, and get into a shelter. Um, Worst case scenario, you're still in that trailer, a tornado's bearing down on you. You want to get out of that trailer and go lay down in a ditch because that ditch is safer than that trailer. And so definitely that's a last resort, but I would much rather be outside in a ditch than in that trailer should a tornado occur. And here's an example of straight line wind damage. Again, this structure was pretty much destroyed by a severe thunderstorm, not a tornado. Straight line winds can be just as destructive as a tornado. And now let's talk about flood safety. So again, flooding, please don't underestimate the power of water. It only takes about 6 inches of fast moving water to knock over and carry away an adult. 12 inches of fast moving water can carry away a small car, and 18 to 24 inches of fast moving water can carry away large trucks and SUVs. Not a lot of water to do that kind of damage. And the other problem is you don't know the condition of the road underneath you. So this sequence of images here shows a road collapse, and I love this sequence of images because I haven't found one any better, and this was several years old. But notice the road here; it's only slightly covered by water. You can see the yellow line, and you might think, "Well, I can get through this." But the problem is you don't know the condition of the road underneath. Look over here to the left. You can kind of get a hint that this road is probably not structurally sound, and I think this sequence of images took about a minute and a half to occur. And so you can see how that road started to collapse, and it would not have handled even probably a regular sized vehicle. Just a small car would have probably that would have trying to drive over that would have caused that to collapse. So while it doesn't take a whole lot of water to move your vehicle, it's also you don't want to drive over a flooded road because you don't know the condition of the road underneath. So we say turn around, don't drown. Most of the flash floods that we get in our region, they're called flash because they just don't last very long. 20, 30 minutes, maybe the water's receded and you can find a either see the condition of the road or find an alternate way around. Some areas affected by river flooding takes may take a couple of days for the water to go down, but most of those cases it's best just to find an alternate means to get around that flooded road. Now, as a spotter, please report flooding. It's very important that if you see flooding, to let us know about it. First off, though, if lives are threatened, call 911. Let them know about the flooding. Let them know that lives are threatened, and they can dispatch emergency responders to that area. But then call us. Let us know specific location information, roads, intersections, creek names, as much information as you can get. All right, so let's do our last quiz question. Oh, well, now I see I just saw how to share results there. That wasn't apparent to me. All right, so let's do, all right, so which of the following events should be reported to the National Weather Service? What do you think? Okay, so reports are coming in. All right, so I'm going to close and share. Yeah, there we go. Well, sorry, it took me to almost the last question to figure that out. So, which of the following events should be reported to the National Weather Service? Uprooted tree after a storm, definitely report that to us. Flooding road, definitely. Rotating wall cloud, definitely. Pea-size hail, only about 50% of folks said yes, but I want to know about it, and I'll tell you why. If I'm on the warning desk and I'm seeing a storm, we've got all these algorithms that tell us or give us an estimate of what the radar is sensing as far as hail size. And if it's telling me that quarters are falling from that storm and it passes right over top of you and you report pea-size hail, well, that helps me recalibrate, and it tells me that the computer algorithm's a little off that day. So yeah, even though it's not severe, I definitely want to know about it. Shelf cloud, you don't have to tell me about it, and that's probably my fault. I didn't really touch this on this, but shelf cloud is more your clue that really strong winds are coming, but you don't need to report the shelf cloud to us unless it causes damage, and then we would want to know about the tree damage or the structure damage or whatever the damage that shelf cloud produced. So very, very good. All right, so let's hide that. And let's talk about winter weather spotting real quick. As far as lessons from the past when it comes to winter, well, it's been a while. I think we maybe not even 3 inches of snow in Charleston this winter. Pretty pitiful. But you can see the map on your right shows the greatest one-day snowfall on record for any given counties. And you might not be able to see it, but there's actually some 1987s on here. Jackson, Benton County, Ohio, 1987. Perry County, Ohio, 1987. See if I can find any more. And I say that because that storm actually happened in April. So while I think we're done with winter, you never know. Maybe we'll get our winter late this year, but it doesn't look that way. But I did want to bring that up. We may not be done with snow just yet. But you can see Charleston's third greatest snow on record was April 2nd through 5th, 1987. And Elkins also was April 1987 was their second greatest snowstorm on record. So if you've been around a while like me, you remember that storm. But other than that, very rare to get any more snow this late in the year. But we are very appreciative of spotter reports. And so if next winter, hopefully you remember, and hopefully you'll watch our winter spotter training that we do typically every November. But snowfall is one of those things that we don't have any automated equipment measuring snow for us. We rely on human beings to stick a ruler in the snow and tell us how much snow's occurred. It's really helpful for folks to tell us when there's freezing rain occurring, and you can use that MPing app to really let us know what's going on in your community when it comes to winter weather. But snowfall reports are very important, and so just keep that in mind. So let's review real quick what we need to know about. We need to know about tornadoes. We need to know about funnel clouds. And if you think you see a funnel cloud, remember, ask yourself 2 questions. Is it rotating? And where's it pointing? And if you've got debris being kicked up at the ground, then that's a tornado, not just a funnel cloud. Wall clouds. And if there's rotation, that's key. That tells you it's a wall cloud. Wind or storm damage, even if it happened in the recent past, maybe you've been at work all day, storms passed through earlier in the day, you come home, you see damage. We still want to know about it. We still document this stuff and want to know about damage. Even though it's not helping us for warning decisions, it's still very important information for us. We want to know about the largest hailstone that you see. We want to know about flooding. Again, that's a big one. And if you've got a weather station and maybe you get an inch of rain in an hour or more, let us know about it because it's probably getting close to the threshold for flooding. Okay, what next? So in about an hour after this webinar completes, the GoToWebinar software will push out an email to everybody that has signed in and taken this class. And so I do encourage you to follow the instructions in that email. One of the things that will be in there is a form that will ask for your location, your contact information, and we keep that internal. We never give that out, but we use that information. We put you in our database, and that way we may reach out to you at some point if severe weather is expected in your area. Usually we don't contact too many folks. Typically folks contact us first, but if we're looking for some ground truth, we may occasionally reach out to our spotters and call that number. So it's very important that you let us know your location. Your email is very important because I do send out emails occasionally just as a to keep contact with our spotters and to let you know when there's a significant storm coming and kind of use that as a spotter activation tool. So email is very important. But again, we keep that all internal. And so that email will show up in about an hour. And so follow the instructions on there. Or you can scan the QR code on your screen. That'll take you to a web page where you can access that form right now. After you complete the form, I'll get an email saying that you did it, and then I will respond with our weather spotter hotline number and some more information. Now, it may take a couple of days, so be patient with me, but I will be in contact with you once you complete that spotter contact form. And there'll also be a link in that email to provide feedback on the training. I do appreciate your feedback. It is anonymous, but is much appreciated. Okay, there are some additional training resources available for you. Again, our Weather Spotter page has or will have the recording of this presentation on there. Spotter Network is a great resource for you. There's a lot of good training on there, and spotternetwork.org. And then Jetstream is a National Weather Service resource where you can learn all about weather. And so if you got kids that are interested in weather or science, send them to weather.gov/jetstream, and they can learn a whole bunch more information. I do encourage you to, if you've got some spare time on your hands, to think about volunteering for the Red Cross. You know, Red Cross is one of our partners, and they do some really great work after the storm, helping people get back on their feet. I know house fires in our area, they really come in after the fact and really help folks. So here's a contact to go to redcross.org/volunteer if you're interested. You can really help some folks out by becoming a Red Cross volunteer today, and they are in need of volunteers in our region, so definitely something to consider. Okay, so let's get to questions. So I'm going to look back through our questions here and answer them one by one, but if I don't get to your question, don't hesitate to message us on social media, direct messages, tweet us, whatever, anytime you have a question. All right, so let me go through the questions here. Okay. Okay, so the first question I see is from Rustine. Are you able to adjust the angle of the Doppler radar? Let me turn my camera on so I can see you all. That's a very good question. And yes, while we don't, so yes and no. So our radar basically on its own, it will take, it rotates around and it adjusts angle. And so it'll start out at 0.5 degrees elevation, and as it rotates around, it goes higher and higher and up in the atmosphere. And it typically takes about 4 minutes to go from a half a degree elevation to 19.5 degrees elevation, and then it starts over. Now we have different volume control programs in there called VCPs, and they allow us to change how often we sample the lower part of the atmosphere. So it's kind of complicated, but basically it's not just a static, you know, radar. It's always rotating, it's always adjusting its angle and letting us see storms, and so that's very important. So very good question. Let's see here. So as a registered spotter already, I also got my ham license this past June. Is there a way to correlate the two? Well, welcome, Sarah, to ham radio. I'm a ham radio, I have a ham radio license myself, general class operator, KJ4FYM. So welcome. And what you can do is, I have a question on the form that you'll get asking for your information. Yeah, tell us your ham radio, put your ham radio information in there, and we'll put that in our database so we'll know that you're a ham person. So really appreciate that. That's great having another ham out there. Let's see. So Russ is talking about TV stations reporting temperatures 70 degrees when it's really around 30 to 40. I'm not sure where they're getting that information from. Occasionally, automated equipment goes kind of haywire, and maybe they're passing on that report. I'm not really sure. Let's see. Does your office have the ability to take severe weather reports via amateur radio in the event internet and phones are out? Hopefully we will very soon. Like I said before, we've got 2 meter 440, so we can communicate locally. We have a HF rig, and we have hopefully get that before too long. So it's something I've got to work out. We do have redundant communications here. We have a backup generator. We have multiple ways of getting communications as well. But in a catastrophic event, that's why I wanted ham radio, is to be able to communicate. So that's a very good question, and something we're going to be working out there, Nathan. So thank you for that question. Let's see, Lawrence is, are you interested in other tornadoes from 2016? Sure, yeah. Like I said, a lot of times tornadoes don't get documented. So if you're aware of damage in your area, you could send me the information by email. My email will be on the email you get here about an hour, but it's tony.edwards@noaa.gov. I'd love to see what you got there. Tammy, the slides were dragging for me, so I wasn't able to answer the last two questions. Sorry about that. Yeah, internet can be good, can be bad, so no worries. If we are spotters, we don't need to do the online form, correct? Yeah, that's correct, Suzanne. If you do it, no big deal. I always look at the database, see if you're already in there. And if you're already in there, I just look to make sure all the information's up to date. And if not, you're good to go. Let's see. Michael, good to see you on here. Coco Roz, yeah, I would mention Coco Roz. Always looking for new volunteers. It is March, and it's a kind of a March Madness thing going on with Coco Roz. So the more volunteers we can get to join that, the better. I did mention that. And amateur radio, yeah, we will be working on that. Try to get out with some clubs around the area and see what we can do as far as getting back on the air and getting more amateur radio participation in Skywarn nets and what have you. See, somebody uses Radar Scope. Is it good? It's our radar. I use Radar Scope. It's a great app. Any app out there that you're using that has radar data on it is our radar data. So just keep that in mind. They may repackage it, make it look a little different, but it's basically our radar data, and Radar Scope is a very good app. Have you read the book, The Charleston Tornado? I'm not sure if it's still in print. I have, we have a copy of that. I have looked, yeah, we have a copy of that in our library, if I'm not mistaken. So I have looked through it and seen that. It's really remarkable storm. And of course, 1944 is when it happened. So we've advanced quite a bit, David. But yeah, that's a very good story to read about that Charleston tornado. Ah, Jared, which should you trust, the GFS model or the Euro model? Yeah, it depends on the situation, and a lot of times we're looking at all kinds of different models, and we call it ensemble approach. And usually one model's not 100% correct all the time. So, but it just depends on the situation there. Sean, don't be scared, be prepared. Very good. Yes, yes. Okay, so here's Matthew says, I live in Morgantown now, but I work in Bridgeport and originally registered to be a spotter there years ago. I know the Charleston office doesn't cover Morgantown. Can I be a spotter for both offices? You can. Yeah, we'll take your information, and then I can also share it with Pittsburgh, and so you can be a spotter for them as well. So very good. Just fill out that form, and I'll make sure that both us and Pittsburgh know your information there, since you go back and forth across that line. All righty. Awesome. Deanna, thank you for the comment. And good, we need spotters down around that area of Dickinson County. So awesome. Yeah, love it. Thank you for the comments and for being a spotter for us. Marshall University has a newly formed ham radio club. Awesome. Yeah, Sarah, reach out to me. I'd be happy to come talk to the club there. And yeah, you'll get my email, Sarah. When it'll be on the email you get, you'll see my email, tony.edwards@noaa.gov. Send me some info on it. I'll be happy to come talk to the group there. Awesome. Radar Omega. Yeah, I've heard about that, Dawn. It is a good app. How do you know if you're a trained spotter? Jared, just go ahead and fill that form out. You'll get in about an hour, and I'll look in our database and see if you're a spotter. And if not, we'll put you in the list. I appreciate the comment, Patrick and Russ. Yeah. And can you still bounce information to another weather service office if needed, if we're on the road? Yeah. Yeah, Gretchen, if you're on the road, and like I said, that app, or excuse me, the spotter webpage is a great way to do that. But if you want to call us and something's going on, we'll be happy to pass that on to the other weather service office if you don't know their contact information. William, real-time lightning app, so you know when it's time to disconnect. There's several apps out there. I think I'm drawing a blank. Let's see here. Stand by. There's just the Lightning app is an app that you can use. WeatherBug, I think, has a lightning tracker on it as well. So yeah, just go to your app store and just search for lightning. There's a couple of them out there. The lightning app is the one. It's got a yellow icon with a black lightning bolt in it, and it's the one that I've used in the past and had some pretty good results for. So good question. All righty, and thank you, Bradley, for the comments. So I think that's it. It's all the questions I see. Let's see. Awesome, Randall. Got the weather station on Weather Underground. Yep, we monitor that. Awesome. Yeah. Okay. Yeah, and there's also, yeah, we do have NOAA has a real-time lightning page. It's actually satellite derived radar data. There's a whole bunch of information out there. As far as apps go, though, that can actually send you an alert when lightning's about to hit the area, that My Lightning Tracker is a pretty good one. So, I didn't know the MPing app is not able to be used on new Androids. Hopefully they fix that pretty soon there, Bill. I wasn't aware of that. All right. All right. So, we're going to end it now. I really appreciate your all joining. And again, look for the information coming here in a little while in your email, and follow that, and we'll register you as a spotter. And please, if you see any of the stuff that we talked about, don't forget to let us know about it. It's very important that we get your information. It can really save lives. So really appreciate it. I hope y'all have a great rest of your evening, and stay safe.